Today we're tackling HQT-4210, 7 specific questions covering Hitachi NAS platform concepts that trip people up on the real exam.
Yeah, we'll look at some seriously practical stuff like, upgrading hardware, untangling management networks, and what to do when your interface stops responding, but your file services are actually still running.
Exactly. So let's jump right into some real problems so you can see how these topics get tested. First scenario, imagine a customer wants to refresh an older HNAS system, but they want to keep the exact same client protocols.
Right.
What's the best comparison to help decide the correct replacement model?
Well, if I'm thinking about this logically, their main goal is just keeping those same protocols. So, I mean, it's really tempting to just check whether the new model supports SMB and NFS and call it a day. Right.
Oh, that is the classic trap. I mean, protocol support is necessary, but it's not enough.
Yeah.
To actually size a replacement, you really have to compare model performance, port counts, memory, and scale limits.
Exactly. I like to tell my teams, just checking for SMB and NFS is like buying a heavy-duty work truck based solely on whether it has a radio.
Right. Totally ignoring the towing capacity.
Yes, you can't just look at external array capacity or RAID layout either because, well, that's the back-end storage side. It's not the actual NAS platform specs.
That's a great analogy. Choosing the right hardware immediately leads to how you plug it in, though.
True.
So during deployment, imagine an engineer connects users, SMU access, the system management unit, and service traffic all to one flat subnet. How do we fix that design to align with best practice?
A flat subnet is definitely messy. Some people might think, hey, let's just place all the cluster heartbeat traffic on the front-end client ports to separate it out.
Oof, no, please don't do that.
Wait, why not?
Mixing your internal cluster control traffic with your external client data traffic is just a disaster waiting to happen. The right move is to physically separate public SMU access from the private management devices.
Oh, right. Okay, so you're separating the public VIP entrances from the private employee service doors?
Exactly.
Because if you put your private interface on the public subnet, you're exposing all that internal wiring. And, I mean, just relying on IPv6 link local addresses isn't a complete management design anyway.
Spot on. Speaking of physical separation and layout, let's say a field engineer is mapping an HNAS rack before installation.
Okay.
What do you absolutely have to validate during this architecture review?
My instinct is to jump straight to the logical configuration, like setting up browser certificates for web sessions or, configuring SMB share permissions for the users.
See, you're jumping way too far ahead there. You need the physical foundation first.
Oh, true.
You have to validate the front-end ports used for client traffic, along with the power, the cabling, and the node-to-node interconnects.
Ah, I see. It's like inspecting a house's physical plumbing and wiring before you worry about, assigning bedrooms to people. You can't configure permissions if the nodes can't physically talk. And, well, we don't look at back-end storage connectivity yet, right? Because that relates to the storage design, not the NAS heads themselves.
Precisely. But once that physical foundation is set, the software layer takes over. So try this mystery.
Hit me.
After a reboot, file services start normally, but your team cannot manage the virtual servers from the expected interface. What software layer view helps isolate this?
Well, if the system is acting up after a reboot, my first thought goes to the disk shelf firmware or the RAID groups. Maybe they didn't initialize correctly.
Think about the symptoms, though. If the file services are running and serving data, the disks are actually doing their job perfectly.
Wait, really? Oh, I see.
Yeah, the culprit is the NAS OS services, the enterprise virtual server functions, and those management daemons.
Ah, that makes total sense. It's like a restaurant kitchen that's still cooking food perfectly, but the host stand is locked, so the manager can't seat anyone new.
Love that.
So it has nothing to do with client DNS or license files, since those wouldn't cause a service daemon to just fail on boot.
Exactly. But speaking of licenses, what if the interface works perfectly, but a specific feature just won't enable on a new node? The engineer suspects licensing. What should they check first?
Oh man, I've been burned by browser cache glitches so many times where a page just holds on to old data. I'd probably clear the cache.
I feel that pain, I really do. But here, the UI is accurately showing you the feature. You just don't have the keys to the car.
Oh, so you have to check if the correct license key is actually installed and active.
Right.
It's just like premium TV channels showing up in your cable guide but giving you a blank screen until you actually subscribe.
Yeah.
And checking client VLANs or NFS exports won't help here because those have absolutely zero relationship to feature licensing.
Definitely. Activating those features requires the right sequence from day one, though. If you're installing a single-node HNAS with an embedded management unit at a branch site, what sequence reduces rework?
Well, people always want to get to their data immediately, So you might think you should create the file systems first and then assign the management IP addresses later.
Backwards again.
Really?
Yeah, you need an active phone line installed before you can start making calls. The correct sequence is configure your SMU networking, discover the server, and then run the setup.
Got it. So management connectivity has to be established before server setup. If you start building file systems too early, you're just flying blind.
Exactly.
And since it's a single node, you wouldn't do any steps related to clustering, like adding it to a cluster just to convert it to standalone later.
Spot on. But that sequence absolutely changes when you expand, which brings us to our last scenario.
Okay.
Your team is building a two-node HNAS cluster. What action best supports a stable initial configuration?
Let's keep things simple here. If they are a cluster, they act as one. So just give both nodes the exact same private management address.
That'd cause a massive IP conflict. No way.
Oh, wait, yeah.
You have to assign unique node management addresses and verify quorum.
Of course. Two co-captains need unique walkie-talkie frequencies to coordinate, rather than yelling over the passenger PA system.
Right.
Relying on client data interfaces for cluster chatter is a terrible idea. You need that dedicated, unique management line. Whether it's a single node or a cluster, your management network is your lifeline.
That's all the key points we shared for the HQT-4210 exam today. Thanks for watching. If you found this helpful, subscribe and leave us a comment.